we are looking at Mercury 2, the world's fastest reasoning language model, built to make production AI feel instant. It was created by Inception, a deep tech AI research company founded by the very scientists who pioneered foundational breakthroughs like flash attention, decision transformers, and early diffusion models. Backed by industry heavyweights like Andre Karpathy, Andrew Ng, and Eric Schmidt, their team is shifting the entire paradigm with a completely new foundation: diffusion for real-time reasoning. Mercury 2 doesn't decode sequentially. It generates responses through parallel refinement, producing multiple tokens simultaneously and converging over a small number of steps. Think of it as a less typewriter and more editor revising a full draft all at once. The result is blazing fast performance you can actually notice. Let's look at the benchmark. When tasked to write code for an LLM inference function, Mercury 2 completes the task in just 14 iterations, compared to the 87 iterations required by the standard autoregressive model. In real-time voice application, it resolves user queries in 11.14 seconds, making it 2x faster than Claude Haiku 4.5. And when running instant agents for complex tasks like designing a website for a small business, Mercury 2 finishes the job in just 10.03 seconds, running a massive 3x faster than Haiku's 4.5's 35.19 seconds. Overall, it delivers greater than 5x faster baseline generation. It hits 1009 tokens per second on NVIDIA Blackwell GPUs, shifting the entire quality speed curve for production deployments. It is OpenAI compatible, meaning you can drop it into your existing stack today with no rewrites required. Mercury 2 is live. Go ahead and try it out. Welcome back to Sumantra Codes. If you are new here, I'm Sumantra, a senior software engineer, and I break down industry-grade AI and system architecture so you can stay ahead of the curve. The engineering community is currently debating an important architectural pivot. We are beginning to see viable models move away from sequential word-by-word generation towards parallel document-level generation. To understand why, we have to look at the massive bottleneck holding AR or autoregressive models hostage. Why can't we just make autoregressive model faster? Why can't we just throw 1000 more H100 GPUs at the problem? Because of the ON sequential generation trap. Autoregressive models suffer from left to right lock-in. To predict token number 100, the model absolutely must compute token 99. It is strictly sequential. You might be thinking, just add more compute. But single batch autoregressive generation isn't compute bound. It is memory bound. For every single word generated, the GPU has to load massive weight matrices and the entire KV cache from the memory into the processor. You are waiting on memory bandwidth, not raw processing power. It's like having 1000 horsepower engine but a fuel line the size of a cow straw. And it gets worse. Autoregressive models have a no backspace problem. If an AR model makes a tiny logical error on token 10, it is mathematically forced to hallucinate the rest of the sequence based on the faulty premise. It cannot go back and fix it. Enter text diffusion or DLLMs. This is the aha moment. How does Mercury 2 hit 1000 tokens a second parallel decoding? An AR model starts with your prompt and an empty void. A DLLM does the exact opposite. It starts with massive block of pure noise, static, that represents the maximum sequence length. Instead of writing word by word, the model takes 20 to 50 simultaneous passes over the entire sequence. It acts like a sculptor, carving away the noise all at once. Because it's denoising the whole sequence simultaneously, it has bidirectional influence. Token 50 can actually influence token 5 during the drafting process. It serves an invisible backspace key. If the end of the sentence dictates that the beginning should be structured differently, the diffusion process adjusts it before the final output is served to you. It is a paradigm shift in machine logic. Now let's flex some technical depth. If diffusion model is so great, why did it take until now to crack it for text? We have had image diffusions like Midjourney for years. It comes down to one fundamental mismatch. Images are continuous, text is discrete. With an image, you can mathematically blend a blue pixel and a red pixel to get purple. The math is smooth. You can apply Gaussian noise incrementally. So xt is equal to square root of multiplication of alpha t and x0 plus square root of 1 minus alpha t epsilon. but you cannot blend the words array and apple. There is no halfway point between the two words. To solve this, researchers use latent space mapping. They take discrete text token and force them into mathematical embeddings, essentially turning rigid words into continuous coordinates in a high-dimensional space. Now, the Gaussian noise math works, but here is the clunkiness that took years to fix. At the end of denoising process, the continuous math has to snap back to a rigid discrete word in a dictionary. For years, this snapping process caused massive instability and gibberish output. Mercury 2 tried to finally stabilize this snap. If this is the future, why are OpenAI, Anthropic, and Google are still shipping autoregressive models as their flagships? Are they just behind? No, it's about the trade-offs. First, there is the RLHF nightmare. Reinforcement learning from human feedback is the secret sauce that makes model helpful instead of chaotic. But RLHF is designed to reward a model step by step, left to right. Try to assign a reward to a chaotic parallel denoising process is a mathematical nightmare we haven't fully yet solved. Second, the logic gap. Because AR models generate left to right, they naturally create a chain of thought. They think out loud. A diffusion model tries to jump to the conclusion at the exact same time. It writes the premise. For deep logical reasoning, autoregressive model still wins. Finally, don't underestimate the trillion-dollar moat. The entire global software stack, from CUDA kernels to flash attention, is hyper-optimized for autoregressive generation. Switching the entire world's infrastructure is incredibly expensive. So what does this mean for your daily workflow right now? It means you need to stop treating AI as a one-size-fits-all tool. If you're doing complex system design, writing long-form architectural documents, or need deep chain of thought reasoning, stick to heavy AR models like Opus or GPT-5 tier. But if you're building agentic workflows where speed is everything, like real-time voice agents, rapid code autocomplete inside IDEs like Cursor, or doing massive parallel data extraction from thousands of documents, text diffusion and models like Mercury 2 may become your new best friend. You are matching the tool to the topology of the problem. Let's recap what we have learned today. First, the bottleneck. Autoregressive models are trapped by ON sequential generation and memory bandwidth. Second is the solution. Text diffusion uses parallel decoding and bi-directional context to shatter the speed limit, hitting 1000 tokens a second. Third, the math. We bridge the gap between continuous noise and discrete text using latent space embeddings. Fourth is the use case. Use autoregressive for deep logic and DLLMs for instantaneous agentic execution. Now I want to hear from you. Which workflow are you going to plug a 1000 token per second model into first? Drop it in the comment below. I read every single one. If this breakdown helped clarify the madness of the current AI landscape, hit that like button. It genuinely helps push this to other engineers who need to see it. Share this with your dev team and don't forget to subscribe so you don't miss our upcoming deep dives. Until next time, keep building. I'm Sumantra. I'll see you in the next one.